Hello my dear students, today we are going to learn this next topic, that is types of pavement. Till now we are known that there are basically two types of pavement, that is flexible pavement and the rigid pavement. Flexible means which is susceptible to change and rigid means which do not undergo any deformation, any change. So its design part we are going to study, but firstly let us focus on a flexible pavement. Flexible pavement are those which on a whole have low or negligible flexural strength and rather flexible in their structural action under load. So how is the load transfer? Load is transferred to the lower layer by grain to grain distribution as shown in the figure below. Now see here, when the load is applied on the surface, each grain will distribute the load to the underlying surface. The wheel load acting on the pavement will be distributed to the wider area and the stress decreases toward the depth. Flexible pavement layer reflects the deformation of the lower layer on the surface layer. See now the figure here is showing you that this is a wheel which will be moving across a road. This is a road surface and over which the wheel will be moving. Once it will be moving, the load once it comes in contact with the surface, it will get distributed over a wider area as and when it goes in the downward direction. Okay, so this is nothing but a cross section of a flexible pavement which we will study in depth, which we have already studied in depth. Okay, now typical cross section of a flexible pavement. Typical cross section of flexible pavement, at the bottommost portion there will be a compacted subgrade over which there will be a subbase course, base course, binder course, surface course, and topmost portion will be a surface dressing. Okay, in between this binder course and base course there is a prime coat, and in between this surface course and binder course there is a tack coat, and base course and binder course there is a prime coat. So typical layers of a conventional flexible pavement include seal coat, surface course, tack coat, binder course, prime coat, base course, compacted subgrade, and natural subgrade. So what is a typical layers of a flexible pavement? Seal coat. Seal coat is a thin surface treatment used to waterproof the surface and to protect it from skid resistance. Tack coat is a very light application of a asphalt emulsion diluted with water, and it provides bonding between two layers of binder course. Prime coat is an application of low viscous cutback bitumen to an absorbent surface like granular bases on which the binder layer is placed and provides bonding between two layers. Surface coats is directly in contact with the traffic loads and are constructed with a dense graded asphalt concrete. Binder course purpose is to distribute load to a base course. Binder course requires lesser quality of mix as compared to course above it. Base course provides additional load distribution and contributes the primary functions to provide structural support. It improves drainage and reduces the intrusion of fines from the subgrade in the pavement structure. Then comes the subgrade. The topsoil or the soil grade is a layer of a natural soil prepared to receive the stresses from the layers above. Now there are several factors which will affect the design of a pavement, like design wheel load, subgrade soil, climatic condition, pavement component material, environmental factors. Now design wheel load. If we consider this one only factor, still then there are various different components or factors included in this wheel load factor, which are maximum wheel load, contact pressure, dual or multiple wheel loads or equivalent single wheel load, and a repetition of loads. Let us learn one by one in detail. Maximum wheel load. Now you know that if there is only a single wheel, it is attached with an axle, right? For a tractor, if you consider, at front there will be a single wheels, and at the back side you can see there are double wheels. So this will be a double wheel. Okay, many times two wheels are attached together to form a four-way compartment, that is called as a tandem axle. Okay, so single axle and this will be a tandem axle. Okay, So these figures are clearly showing you what is a single axle and what is a tandem axle. Now maximum wheel load. The wheel load configuration are important to know the way in which the given vehicle are applied on a pavement surface. Typical wheel load configuration of tractor trailer unit as a heavy loaded vehicle is taken into consideration. These figures are showing you, see now this much portion is showing you the tractor part, and whatever the trolley will be connected to it, it will be a trailer part. So the trailer will be a tandem axle and this portion will be a single axle. Okay. For this type of loading condition, tandem wheel and tractor wheel. Okay. For this type of loading condition, the total load influencing the thickness requirement of a pavement and tire influences the wearing course. Therefore, the magnitude of vertical pressure at a depth of soil subgrade mass depends upon the total load and surface pressure. Now, according to the Boussinesq theory, the equation for the vertical stresses is given by sigma z is equal to p into bracket 1 minus z cube upon a square plus z square into bracket raised to 3 by 2. Now, what are all these? Sigma z is a vertical stress at depth z, p is a pressure surface, a is the radius of loaded area, and z is the depth at which the vertical stresses is determined. This formula you will have to mug up. By using the above equation, the distribution of vertical stress with respect to depth is plotted as shown in the figure. So whatever the value you get, so with respect to depth and vertical stresses, you have to plot a curve, whatever may be the pattern. Then contact pressure. The total depth of the pavement is not influenced by the tire, right? So the stresses caused by the steel tire wheels, that is bullock carts, are maximum, hence very strong and hard aggregates for the wearing surface is required. But the stresses at the lower layer of the pavement caused by the is very negligible. So unnecessary we have to give lot much stress. The wheel load is generally assumed to be distributed over a circular area. Yes or no? So there are three terms used in the tire pressure. Generally, tire pressure, contact pressure, and inflation pressure. So this contact pressure is calculated by formula total load on the wheel area divided by contact area. Simply load on the wheel upon contact area. Here comes one more factor called as a rigidity factor. So this rigidity factor, what exactly this rigidity factor is? It is defined as a ratio of contact pressure to the tire pressure. The rigidity factor depends upon the degree of tension induced in the walls of the tire. Now this is an important technical term called as ESWL, that is equivalent single wheel load. This can again be derived from the graph. Okay. Now dual wheel assembly to the rear axle of the road vehicle is provided by the two main reasons. One, to maintain the maximum wheel load within the specific limit, and to carry the greater load. Now equivalent single wheel load can be determined based on the equivalent stress criteria or equivalent deflection. Multiple wheel loads are converted into single wheel load, and this converted value is used in the pavement design. For example, suppose a certain value of maximum deflection A at a particular depth Z is caused by a dual wheel unit or assembly, then according to the deflection criteria, the equivalent single wheel load is that single wheel load of same contact pressure which imparts the same value of maximum deflection at depth Z. In such manner, with the help of the stress criteria, the equivalent single wheel load is that single wheel load which produces same value of maximum stress at a required depth Z as the dual. The equivalent single wheel load is usually found by the equivalent stress criteria from the graphical method. Now in this method, a straight line relationship is considered between the equivalent single wheel load and the depth Z on a log-log scale. This figure is shown on a log-log scale. The graph of depth Z and equivalent single wheel load is plotted, and in this graph as shown in the figure, 2 points and R are plotted on log with the coordinates as Q and R with 2P and 2S. Okay, and line is drawn joining to Q and R. Locus of this point where any single wheel load is equivalent to certain set of the dual wheels. To calculate the equivalent single wheel load for a dual assembly, it is essential to estimate the design thickness of the pavement. Thus, equivalent single wheel load is obtained at the assumed thickness from the graph. The same is used as a design for calculation. Note that if the design thickness obtained is equal to estimated thickness, then the equivalent single wheel load calculated are correct. If not, trials are made till the design thickness so obtained becomes equal to the estimated thickness. The load on each wheel in case of heavy tractors can be further reduced by multiple wheels and tandem axles. Now next important factor is equivalent wheel load factor that we'll learn in next class. So we'll just stop here. Thank you.